Hello chemists! In this section of the video we'll be learning how to write and balance equations, or at least review, because you should have been able to go over this in honors chemistry. I say it's going to be your soon-to-be favorite part of chemistry only because it's one of the few concept-based blessings as opposed to math that appears very often in AP. So the process you'll have to go through is, to begin balancing, you have to count the number of elements on each side. So let's use this equation as an example. We have AgNO3 and H2S. And then the products of the equation are going to be Ag2S plus HNO3. So on the reactant side, which is the left side here, we have 1 Ag, 1 N, 3 O, 2 H, and 1 S. Now make sure that whenever you're looking at this, you always make sure that when there's a number, whether it's a coefficient or a subscript, that it applies to whichever element it's supposed to be. So had this been something like 2HS, then you would have 2 hydrogen and 2 sulfur. But that's not the case. Here it's H2S, so you only have 2H and 1S. On the product side, we have 2 silver, 1 sulfur, 1 hydrogen, 1 N, and 3 oxygen. So we need to make sure that the reaction is going to run completely. So the moles of everything on each side have to be the same. Something that helps, especially when you're starting off to balance, is make sure that you do it in this order. You're going to find your metals to be equal, then your non-metals, your hydrogens, and your oxygens. After a while, and especially when you're in AP, it gets to be a breeze just to be able to see, oh, I can eyeball this and get it correct. But so here, let's classify them. So for my metals, I have my silver. Non-metals, I have my nitrogen and my sulfur. And then obviously my hydrogens and oxygens. So now what you can do is, what I like to do is actually write right beneath the equation how much I have on either side. So I'll put my metals first. Here's my Ag, then my non-metals, so N and S, then my hydrogens, and my oxygens. So how many do I have on my reactant side for silver? Well, just 1. And on my product side, I have 2. For nitrogen, I have 1 and 1. Sulfur, I also have 1 and 1. For my hydrogens, on the left, I have 2. On the right, I have 1. And on the left, for oxygen, I have 3 and 3. So, first thing, I can already tell that my silver is not balanced, and that's the first thing I need to find. So, what I could do, I'll write it right here so you guys can see, is for my AgNO3, I can put a 2 in front of it, and then that'll distribute to everything here. So, I will end up increasing my Ag to 2, my N to 2, and my oxygen to 6. So now that'll affect what I need to do on the other side as well. So now that my silvers are balanced, I can move on to my non-metals. So on the right side, I should try to balance my nitrogens. So if I take this, HNO3, and I plug in a 2 in front, that'll distribute to give me 2 hydrogens, 2 nitrogens, and 6 oxygens. Well, even without going in order, I can already see that my oxygens are going to begin to balance. So there's a 6 there, my nitrogens also become a 2, and my hydrogens become a 2. So, let's double check to make sure everything's okay. I have 2 silver, 2 silver, 2 nitrogen, 2 nitrogen, 1 sulfur, 1 sulfur, 2 hydrogen, 2 hydrogen, 6 oxygen, 6 oxygen. Alright, everything works. Our last step will be to write the equation again, except we'll add in the coefficients that we place. So, AgNO3 plus H2S yields Ag2S. Let me erase this. And HNO3. So what I did when I erased what we had written is I underlined the AgNO3 here and the HNO3 just so I could remember which ones I changed. So whenever I'm writing these out, I like to leave a little space. Imagine if you have a little underscore here for the coefficients you can place. So we made our HNO3 2 in front, and our AgNO3 also 2. So in some honors chemistry things, you may have written 2, 1, 1, 2 to show the coefficients of each of the compounds, but it's always best to just write out the entire thing so you can visualize where they go. Let's just do one more example here, a little more advanced, what you'll be learning later in your AP Chemistry course. So aside from getting your compounds and just plugging them straight in to get your balance, you also need to know how to be able to convert, regular English into your chemistry knowledge. So, like this equation, iron 3 chloride plus calcium hydroxide yields iron 3 hydroxide and calcium chloride. So, you'll be able to need to come up with the compounds themselves for you to balance. So, if you remember, the Roman numerals after these metals indicate that there's going to be a charge on them. So iron 3 chloride is going to be iron with a +3, and then if I know that my chloride has a -1 and my charges need to cancel, I'm going to need 3 chlorine to balance out, so I have a -3 and a +3 charge. For calcium hydroxide, I know my calcium has a +2 and my hydroxide has a -1. So, and remember your parentheses, I'm going to need 2 hydroxides in order for this to balance. Iron 3 hydroxide, same deal. Fe +3, OH -1, going to need 3, and then CaCl, that's a -1 and a +2. I'm going to need 2 chlorine. So now that we know what our compounds are going to be, I'm just going to write it out a little smaller so we have room to work. So here I have written the entire equation with a little bit of room for the coefficients that will add in. And then underneath I wrote the elements that are included. And even though OH is kind of its own element here because they stay together throughout, I just wrote them separately because you need to stay in that habit as you're going to be writing them later in the year. So let's start off with our metals. So my iron and my calcium. On both sides, they're 1, so for now that's good. For calcium, again, both sides, they're 1. For my chlorine, though, I have 3, and then I have 2. For oxygen, I have 2, then 3. And for my hydrogen, I also have 2, and then 3. So, you can kind of tell that you're going to need to change your chlorine and oxygen and your hydrogens, kind of swap the numbers there so that they both get to 6 as opposed to the 2s and the 3s. So I'm going to go to my chlorine first, and I see that I'm going to need 2 right here, and that'll distribute to give me 2 iron and 6 chlorine. And then on the right side, I'll change my chlorines to equal the 6. So what times 2 is equal to 6? 3. So instead of changing my iron like I did on the other side, it actually changed my calcium. So my calcium is going to become 3. My chlorine is going to become 6. So my chlorine's good now. I can move on to something else. I can either go to my iron or my calcium to get those fixed, or I can continue down the chain where we started. So I'll go to my oxygens, which will also change my hydrogens. So if I have 2 on the left and 3 on the right, I'm going to go and change to get 6 again, because that's the least common factor, essentially. So I'm going to change my 2 on the left to a 3, and that'll distribute to give me 3 calcium and 6 oxygen, along with 6 hydrogen. And on the right, I'm going to put a 2 here. That's going to change my iron to 2, my oxygen to 6, and my hydrogen to 6 as well. And the reason why I had begun to write the 2's here, as opposed to in the actual equation, was just in case that the numbers didn't work, because you'll find later that a lot of the times you're going to keep on changing the numbers because they end up not equaling on either side. So I'll just erase these and put them as part of the equation, so you can see that it is indeed a final product. And the last thing you're going to do is, of course, always important, you're going to make sure that they are equal. So 2, 2, 3, 3, 6, 6, 6, 6, 6, 6. Yes, they are all equal, and this is your final equation.